Welcome to the sixth grade Science A open house. I'm going to be talking about the Science A course for sixth graders. So we'll go through a general overview of the program. I'll talk about my own credentials, and then you'll have a chance to see what a sample lesson would look like in this course. So for the sample lesson, I'm going to be using a previous lesson from the fall course just to give you an idea of what to expect when you sign up for the course. So my name is Galen Tracy. I'm a middle school science teacher. Um, I work at a Houston area private school teaching fifth and sixth grade science. The school I'm at currently is a GT school, gifted and talented, which means that the students are a year younger than they normally would be. So fifth graders are learning sixth grade science, sixth graders are learning the equivalent of seventh grade science. At my current place of employment, I worked 2 years as a lead teacher and head of the middle school science department. I obtained my bachelor's degree in general science with teaching from Temple University, completing the U-Teach program developed at the University of Texas in Austin. So fun fact is, although I went to school in Philadelphia, Pennsylvania, there's actually a connection to the University of Texas in Austin. They were the pioneers of the teaching program that I studied. My general style as a teacher is I do a lot of inquiry-based instruction where students are investigating different topics, given general instructions and taking a more active role in their learning compared to a traditional setting where it's mostly the teacher talking and the students just kind of there for the lecture. I also specialize in personalized instruction. Um, I tend to teach a lot of life skills in addition to science, just because I feel like there are some things that are beneficial for you to learn as a student that aren't explicitly and always taught, right? Like note taking would be an example. When you go to school and you eventually get to high school and college, the expectation is that you already know how to do this, whether or not you've been taught how to note take or been exposed to different styles of note taking. Um, I'm passionate about inclusive education and incorporating visual and physical models to make learning more accessible to students at various levels of proficiency. So the idea here is there are multiple learning styles, and as a teacher, I want to appeal to each of those styles so that everyone is able to learn. In my spare time, I love learning about technology and learning new technology skills, ways to be more effective and efficient as a teacher, right? Anything that will increase efficiency and reduce the amount of time it takes to complete a task, in my opinion, is worth learning. And at the forefront, I believe that uh, artificial intelligence is the way to go. Um, so I have a couple of certifications in using artificial intelligence tools, and I take advantage of that in using it to generate some new original projects that haven't been done before. I also coach about 2 sports per school year. Usually I coach soccer and track, but depending on the year, I might also coach tennis. All right, so this slide here is basically showing you the structure of the courses um, at Momentum Learning, right? So these are other course offerings and where the courses that I teach fit into the bigger picture, right? So students can go from fifth grade science to sixth grade science. As a fifth grader or a sixth grader, you can take a middle school science bowl There's 4 different levels, depending on whether you are a novice or you have more experience. We can see that that leads to pre-AP physics courses. And by the way, these other courses that you see are not courses that I teach, but that are offered by Momentum Learning. If you want to learn more about what courses are available to you, you can scan the QR code in the bottom right corner to learn more. All right, so I'm going to leave that up for a few more seconds, and then we'll go to the next slide. All right, so more about the Science A course, which is called Introduction to Chemistry. This course is an engaging online program that spans 12 weeks, guiding students through the fundamentals of chemistry. Beginning with the exploration of matter, students will learn about its properties, physical and chemical changes, and the states of matter through virtual experiments and multimedia resources. They'll delve into the structure of atoms and molecules, the organization in the periodic table, and the principles of energy transformations. Throughout the course, students will utilize worksheets, practice exercises, educational videos to enhance their understanding of key concepts in a supportive online learning environment. And at the end of my presentation, I'm going to go through a sample lesson plan so you can see exactly what the course is going to look like should you sign up for the Science A course. So this course meets Wednesdays from 6 to 7:30 p.m. CST. From February 5th is the first session through April 30th. It's important to note that there is no class on March 12th in anticipation that many students are going to be on spring break during that time. The 5th grade science course is considered a prerequisite for this course because it will build off of topics that were covered during the 5th grade science session. You may see some similarities, and that is intentional. It's called increasing the level. All right, these are the specific topics that are going to be covered in the course. Week 1 and 2 will be focused on an introduction to matter. So we'll look at the basics of matter, focusing on concepts such as mass, volume, density, and states of matter, how those properties are measured, and how to do calculations through sample problems. Instruction will take the form of worksheets, practice exercises, virtual experiments, TED-Ed videos, as well as other educational videos to identify and describe different types of matter based on their physical and chemical characteristics. The next 2 weeks of instruction will be focused on changes in matter, both chemical and physical. Similarly, this will involve online simulations, virtual experiments, worksheets, practice exercises, and videos. Right, so that's going to kind of be a common theme for all of the topics. And like I said, at the end of the presentation, I'll show you a sample lesson so you can see exactly what a typical session looks like. So during the week where we're learning about changes in matter, we'll also learn about processes such as freezing, melting, evaporation, chemical reactions. The next 2 weeks will be focused on solids, liquids, and gases. We'll learn about the properties and characteristics of the 3 states of matter. We'll also touch on the 4th state of matter, plasma. More on that next week during the first session. Then the next 2 weeks will be atoms and molecules, exploring their structures, chemical bonding, the formation of compounds. We'll learn the basics of atomic structure and how atoms combine to form molecules. The next 2 weeks will be focused on the periodic table, a tool of chemists and scientists around the world. We'll look at how the table is organized. We'll explore different trends within the periodic table and what information it contains. The next 2 weeks will be on energy transformations. So the last 2 weeks will be dedicated to studying energy transformations, the conservation of energy. We'll see how energy can change from one form to another and its significance in different processes and systems. It's important to note that this schedule here is a approximation of what the course will look like. Know that every 3 to 5 weeks of the course, there's going to be a session where we're reviewing the topics so that we retain what we've learned. And so we're really getting the most out of the course rather than just moving on to the next topic, right? So typically it would be like 3 to 4 weeks of a traditional lesson, and then the next one would be a review session where you get a study guide. We play Jeopardy review to test your knowledge, that kind of thing. What I'm going to do now is I'm going to give you a brief tutorial on how to navigate the Canvas website, which is where all the curriculum will be posted. For the 6th grade Science A course, and with the other science courses, the materials are organized by module, which in this case is by week. So all the materials for the first session, the first week, would be found in the week 1 module. All right, so what we're going to do now is I'm going to show you a real course so you can see how it's organized, because I think that's an important point, right? Is I can talk about it all day, but what does the class actually look like? All right, so for this sample, we're going to be looking at week 9, so we can get a lens into what a typical session looks like. All right, so handouts are notes, study guides, lab sheets that are used during the session. Homework is where you'll find the one graded assignment. Typically, the homeworks are worth 30 points, and they're 30 multiple choice questions. Right? Now, as a student, one advantage of this is as soon as you submit your answers, you'll know how you did. You'll see your score. You'll see which questions you missed. During the next session, we would go over common mistakes to address misconceptions. And then we would go to the next topic. Right? So as far as making sure, did you understand the lesson? This is the assessment, these 30 multiple choice homework assignments. All right, so let's go back. Now that you've seen how to navigate, you know from the home page, you just select the week and look for the handouts. Right, so the handouts will be published usually a few hours before the session starts, which will give you a chance to print anything that you might want to. Keep in mind that printing is not necessary, but in most cases it will be helpful in terms of a time saver versus having to write your answers on a loose leaf and go back and forth between a screen. All right, so now that we know how the Canva platform is structured, I'm going to go back to slides presentation. All right, so you saw an example of a warm-up video. You can see notes, right? Lab sheets, the homework assignment, which is the one graded assignment that you'll have a week to complete. And then One of the nice things about this program is after each session, the Zoom session recording will be published to the Canvas site. Right, so this is useful if there's some reason you miss a session, you need to catch up. It's also useful if maybe you just need a refresher and you feel like you want to review what was covered during week one. You have that option with the recording. All instructional materials, including recorded sessions, will remain accessible for an additional 3 months following the conclusion of the course. Zoom and Canvas platforms will be utilized for delivery and access to these resources. Canvas invite will be sent to students, not parents, from Canvas about 4 to 5 days before the class's start date. So this would be 4 to 5 days before next Wednesday. Homework needs to be submitted on time, and it will be automatically graded by Canvas. Like I said, it's a nice feature. You can find out how you did right away. And there's a link to the Zoom session if you wanted to rewatch. All right, so what I'm going to do now is I'm going to walk you through a sample lesson of mine. This will be the abbreviated version. So obviously, it's not going to be an hour and a half like the class normally is, but I'll give you an opportunity to see some of the things that we typically do. So usually after discussing common misconceptions from the previous week's homework, we would begin the lesson with a video. I like to use TED Ed and Amoeba Sisters because they fit right into what we're learning about. Okay, so let's see what the video looks like. Just a few minutes so that we can answer some practice questions and see how that ties in.
You like to organize things. One of us is very organized, maybe a little bit too much. As for Pinky, it's more like she lost a game of Jumanji. But scientists, they are often trying to classify and organize different organisms based on shared characteristics. It's very important to have tools to differentiate among different organisms. So in this particular clip, we're going to use a tool called a dichotomous key to identify 5 different organisms that each happen to be from 5 different taxonomic groups. So what's a dichotomous key? Well, it allows you to identify organisms based on a series of statements that are typically organized in pairs. We are going to use the dichotomous key to determine scientific names for 5 mystery organisms. So what's a scientific name? Often scientific names have Latin or Greek roots, and they can be used across different languages by scientists all over the world. This unification in the naming system is important because common names vary by language and location. They're often far less reliable. For example, this scientific name has a lot of common names such as mountain lion, Texas panther, puma, or cougar. Although those were fun to say. Okay, so let's go ahead and get started. Here are our mystery organisms with clues. We're going to use this dichotomous key. Now we're going to point out that this dichotomous key has been created for use with these 5 specific organisms in the chart, and only these specific organisms. So let's start with mystery organism A, an amoeba. With the dichotomous key, you always want to start with number 1. And if you look at the clues, you notice this organism contains a nucleus. A reminder from our prokaryote-eukaryote video, this means it is a eukaryote. And this tells us to go to number 3. So is this organism a autotroph or a heterotroph? Well, autotrophs make their own food. An example is a photosynthetic organism making food from light energy. But heterotrophs must rely on external food sources. So since our clue states that this organism feeds on other organisms, it must be a heterotroph. And this tells us to go to number 4. Now, in number 4, we have to think about this. There's actually a lot of different species of amoeba, and we don't know what kind it is. but it mentions that this specimen is small because it's saying its size is measured in this unit, micrometers. And if you're wondering what that means, well, it takes 1,000 micrometers to be equal to 1 millimeter. And this particular specimen is definitely microscopic, meaning you need a microscope to.
All right, so we're going to stop there just because you have a general sense of what it looks like. So what I'm going to do is I'm going to stop the screen share a second, and now I'm going to show you what typical questions would look like that go along with the video. In a typical lesson after we watch the video, we have 5 multiple choice questions just to make sure that we understood what we were listening to and to kind of warm up your brain for the lesson. All right, so let's take a look at that. All right, so a typical question you might see might look like this. What is a dichotomous key used for? So I'll answer the first one, so there's no pressure in the audience. So dichotomous keys are a tool that biologists use for identifying organisms. What it is a series of questions that, when answered, will identify the particular animal or species that we're dealing with. So the correct answer in this case would be to classify and identify organisms. Okay, next question. What type of organism does the first mystery organism belong to? So this gives you an idea of the level of attention that you'll need as you're watching the videos, because sometimes the questions are easier, sometimes they really test our listening skills. So in the video, the type of organism that the first mystery organism belongs to was eukaryotes. Right? Another question. Which of the following is a characteristic of autotrophs? Right? So autotrophs are called autotrophs because they're able to make their own food. Heterotrophs, on the other hand, have to consume other living things in order to survive. So autotrophs, in other words, use sunlight to make their own food. Right? So that's what the warm-up questions look like. In the next part of the lesson, what we would do is we would go to the notes. So let's take a look at what sample notes are. Typically, I encourage my students to handwrite their notes. And this is because writing things down makes you more likely to remember the information. I get a lot of questions every year, both at my school and in courses I teach, whether we can type our notes or just print it and keep it in a binder. And my answer is always the same. The notes need to be handwritten so that you internalize the information. It's well established that when we're typing notes, we're not paying attention as much to the syntax of what is being said. We're more focused on the actual words. So we find that students that like to type their notes end up typing more or less word for word what the notes say. And that's not an effective way to take notes. You always want to summarize, put things into your own words. Right? So in this particular lesson, the topic was homeostasis and classification tools. A stimulus is a change in either the internal or external environment of an organism that prompts a reaction. A stimulus causes a response. The response is the reaction to the stimulus and is called a behavior. In animals, the nervous and endocrine systems are involved in stimulus responses. In plants, hormones affect responses to internal and external stimuli. So here's an example showing a feedback loop, which is a way that your body maintains stable conditions in a changing environment. Let's say your body temperature increases. Well, your brain is going to recognize the difference in the temperature of your blood, and that's going to trigger a response. Sweating. Sweating releases the thermal energy as the droplets of sweat evaporate from the surface of your skin. You cool down, right? So we see the action restores balance by decreasing your body temperature. In the same way, if your brain detects your blood temperature drops, that's going to trigger a different response, shivering, which produces heat, thus increasing your body temperature and restoring balance. So homeostasis is a state at which an organism achieves balance in its internal environment by adapting to changes in both its external and internal environment. So it's all about maintaining balance in changing conditions. It's something that's necessary for survival, and it happens at a large scale in organisms, but also on the microscopic scale. Homeostasis happens within the cells that make up living things. It's important to understand that one example of a homeostatic behavior is when animals migrate due to changing seasonal conditions, right? When food is less available, when it's colder, it's beneficial to move to an area where food is more abundant and the conditions aren't as extreme. Thus, we have migration. All right, so I'm going to skip over some of this because, like I said, if I teach it the way it's normally taught, this Zoom call would be an hour and a half. Right, so in this lesson, students learned about variation within species, basically the basics of evolution by natural selection. Right, so it goes into detail on what those specifics are and how that presents itself in living things. They also learn that adaptations are beneficial traits that help animals survive. All right, so I'm going to skip all the way to the end so we can see how that connects to the lab that I assigned for this lesson. Taxonomy is the science of naming and classifying organisms. Phylogenetics is a study of evolutionary relationships among organisms. So scientists use both of these to help understand and classify the diversity of life, all the living things and how they relate to one another. So we can see an example of animal classification for the red fox, Vulpes vulpes. So you can see the different levels of classification all the way from domain down to the species. It's important to note that when we're giving the scientific name of an organism, it's the genus and the species. Right, so genus Vulpes, species Vulpes. Right, so just something to keep in mind if you're ever looking at a scientific name. You can tell automatically what the genus and the species is based on what it says. All right, so this brings us to one of the last topics of the lesson, which is tools that biologists use for classification. In the video, we learned about dichotomous keys, which are a series of questions used to identify an organism. Think of it as like an interview with a species that results in its identification. Right, so we might ask a question, does the organism have fur? No. What about feathers? Okay, suppose it does not. Is its reproduction something that happens externally? No. Does it have gills? No. Well, then it's probably an amphibian. Right, so that's how the dichotomous keys work. Right, so it's called dichotomous because it's a series of yes or no questions, right? The prefix di means two. So the two responses are either yes or no. Dichotomous. Right, so in the next part of the lesson, after the notes is taken care of, we would move on to practice problems. Right, so it's important to immediately apply what you learn when you're learning something new so that it sticks. So we would go through practice problems, usually about 10 multiple choice questions, taken randomly from the homework so that the practice is immediately useful after the session when you go and complete your homework problems. All right, so here are some exemplary multiple choice questions from the past lesson. All right, so you can see it's multiple choice, just like the homework problems. And in fact, you will see those questions when you do the homework. So this encourages everyone to be actively listening as the practice problems are discussed, right? Because then you'll get all of those questions correct. Right, so in the next part of the lesson, I would open up the session to any questions that students have about the topic. And then we would take it a step further and do an interactive lab activity. In this particular lesson, the lab was about classifying sharks with a dichotomous key. So after teaching on the subject, you have a chance to apply what you've learned in a real life scenario. Right, so we always talk about why is this useful? How can I use what I learned in other areas, not just science? Right, so I'm going to show you an example lab sheet so you can see what to expect. So for this lab, you're given some basic information about classification, what a dichotomous key is, a step-by-step procedure to follow. You're introduced to the terminology for identifying the shark with a model that shows you all the different features to look for and their shape. And then for the application, we have a dichotomous key specifically for shark identification. And then we have 14 different organisms that we have to try to identify based on the key. So for each of these, we would go through this series of questions. Then depending on our answer, it would tell us where to proceed. Right? So for example, is the body kite-like if viewed from the top? Let's say it was. We would go to question 12. Does it have a small dorsal fin present near the tip of the tail? If it does, it's probably a skate. If it does not, we would go to question 13. Is the front of the animal having a shape with horn-like appendages? If it is, it's probably a ray. Right? Look at number 14, and that'll tell you what the organism is. Right? So this bottom one, number 14, based on this key, is a stingray. Right? So then the application would be the next time you go to an aquarium, right? Maybe you can challenge yourself to try to identify the shark based on what you know, right? See if you can correctly identify it before you look at the sign and see what it says. Right? So that would be an example of a real life application of what's learned during the session. So then I would give you about 15 to 20 minutes to work independently. And then the last, let's say 10 to 15 minutes, we would go over the solutions to the lab. With the lab, something to keep in mind is you do your best. Okay, if you're not able to finish all of it, that's okay. right? You just answer as much as you can and then listen to the discussion for the problems you weren't able to finish. Right. And then, as always, at the end of the lesson, we would summarize what we learned. And a lot of times I would open up the session for a more informal review. Like we might play a look it game at the end as just like a little additional enrichment. All right. So now you have an idea of what a typical lesson looks like in the science course. Right. So this was, as you can see, this was week 9 of the fall 2024 fifth grade course. That's where it came from.
This is the scientific name.
Right. Moving on. Okay. So as far as signing up, okay, this is a website to find out more about the courses offered by Momentum Learning. There's a phone number that you can call if you're looking for more information. This is the email to use, right? Does anyone have any questions that I can answer?
I have questions. I check on the website, like 2025. Look like they have a like an intro to chemistry. Do they still include the biology or other, other things? Because I saw your, like PDF. Look like you have other things. So I'm not sure, is this coming 12 weeks only for the chemistry, right?
Yes, I was just showing you the fall course so you could see an example of what the lesson plan format looked like. Right, so the topics covered in the spring course will all be related to chemistry. It just so happens that the fall course was more geared toward biology. So that's why the topic was biology.
In the sixth grade, chemistry is only 2 terms, right? It's one is fall and one is spring. So how many topics they covered for sixth grade? Oh,
Okay, that's a good question. So I'm going to zoom out so you can see. This is the original document from which the slides were based. So let me zoom out so we can see starting from the beginning. So you asked about sixth grade courses. So we can see the first 2 courses I taught, summer 2024 and fall 2024 were fifth grade courses. This would be the first session I've offered that's specifically sixth grade science. And at the moment, this is the one course offering for sixth grade science. Now that may change in the future, depending on what the program needs. But at this point in time, this is the sixth grade science course offered.
Okay, so basically it's like a fifth grade and the sixth grade put together, maybe like 1 term. In covered like science, physics, biology, or space, something connected for the middle school, like a middle school. Is that like cost like 2 years, not only like sixth grade? Is that correct? Understand?
Yeah, so the fifth grade course was a prerequisite for the sixth grade one. And then this, at the moment, the sixth grade course is only 1 term.
Oh,
Like
so we didn't join the fifth grade. Can we still do sixth grade, or we have to do some tests or something?
It is there's not any specific restriction to joining the sixth grade course. The let's see, the flow chart here specifies that it is possible to join the sixth grade science course without having done the fifth grade one. Just understand that the topics I discussed will be the ones offered during that course.